Hello everyone. Welcome back to my course, Fundamentals of Thermodynamics, Essential Knowledge for Engineers. In this video, we will talk about basics of combustion in aviation engines. Also, I will be thankful if you give me feedback about this course to make it better and more useful for you. Please write down your thoughts in the comment section or reach out to me via the email provided in my profile. To move an airplane, a jet, or even a small model rocket through the air, we need a propulsion system. The role of this system is to generate thrust, which is the forward force that pushes the vehicle against the resistance of air. Different machines use different propulsion devices, but they all depend on an engine to produce power. For example, rockets rely on rocket engines. Smaller aircraft often use piston or internal combustion engines, and modern airplanes are powered by jet engines. Even though these engines may look very different, they all operate on the same principle. They burn fuel to release energy. This burning of fuel is known as combustion. Combustion is a chemical reaction where a fuel reacts quickly with oxygen to release heat and form new substances. In this reaction, the substance being burned is called the fuel, while the material providing oxygen is called the oxidizer. Fuels may exist as solids, liquids, or gases. In most airplanes, the fuel is a liquid, such as aviation gasoline or jet fuel. In rockets, particularly model rockets, both the fuel and the oxidizer are often stored in solid form. For aircraft engines that operate in the atmosphere, oxygen comes directly from the air. During combustion, the fuel and oxidizer combine to produce exhaust gases. These exhaust gases are very hot because of the heat released during the reaction. When a hydrocarbon fuel, such as gasoline, burns in oxygen, the hydrogen atoms combine with oxygen to form water vapor, while the carbon atoms combine with oxygen to form carbon dioxide. Because air is not composed of pure oxygen, but is instead about 21% oxygen and 78% nitrogen. Some of the nitrogen can also take part in the reaction. This produces additional compounds such as nitrogen oxides, which are often grouped together as NOx. These gases are important because they not only represent energy release in engines, but also play a role in environmental pollution. It is important to note that for combustion to occur, three conditions must be met. There must be fuel available, there must be oxygen or another oxidizer, and there must be a source of heat. Heat is required at the beginning of the process to start the reaction, but once combustion begins, it generates enough of its own heat to keep going. This is why gasoline in your car's tank does not suddenly ignite even though fuel and oxygen are both present. The initial heat source is missing. Once an engine or a fire is ignited, however, the heat produced by the reaction ensures that it continues as long as fuel and oxygen remain available. A campfire is a familiar example of this self-sustaining process. You only need to light it once, and it will keep burning as long as it has wood and air. Because combustion depends on fuel, oxygen, and heat, it can be controlled or stopped by removing any one of these three. Reducing or cutting off the fuel supply will end the reaction because there is nothing left to burn. Removing oxygen will also cause combustion to stop, which is why smothering a fire is effective. Finally, taking away the heat lowers the temperature below the ignition point and the process halts. These principles are applied not only in fire safety, but also in the precise control of engines, where adjusting the fuel and air mixture allows us to regulate power output. Okay guys, now let's have a little quiz. The quiz consists of 4 questions. I'll give you 10 seconds for each one, and then I'll show you the correct answer. Let's start with the first question. Question 1. What is the term used to describe the chemical process of burning fuel with oxygen to release heat? The correct answer is combustion. Question 2. In most airplanes, what form of fuel is commonly used? The correct answer is liquid fuel. Question 3. When hydrocarbon fuel, such as gasoline, burns in oxygen, which two major substances are produced? The correct answer is water vapor and carbon dioxide. Question 4. Which of the following is not one of the three requirements for combustion to occur? The correct answer is pressure. Unlock the world of aerospace engineering with my other expertly designed courses. In Aerospace Engineering, Basics of Aviation Engines, you'll explore the different types of aerospace engines and how they perform, giving you a strong foundation in the propulsion systems that power modern aircraft. Then, take your knowledge to new heights with Aerospace Engineering, Aerodynamics and Structures, where you'll dive into the design and performance of aerospace structures and their aerodynamic behavior. Finally, expand your expertise with Aerospace Engineering, Avionics and Aerospace Systems, where you'll learn about the critical electronic systems that control and monitor modern aircraft, bridging the gap between engines, structures, and flight systems. Whether you're a student, aspiring engineer, or aviation enthusiast, these courses will equip you with essential knowledge to understand and contribute to the future of aviation. Join hundreds of learners and start building your aerospace journey today. Thank you guys for watching this video. If you have any questions about this lesson, feel free to ask me in the comment section. I will answer as soon as possible. We can continue to the next lesson and learn about standard atmospheric model. See you in the next video. Bye.